those who are 50 years old, in this lesson we have the techniques and applications of definite integration. Alright, so let's take a look at this example we have. In this example, we have a double integration e to the power of negative x squared dx dy, where this double integration is done over the boundary of d, where d is bounded by y is equal to x is equal to 1, and the x-axis. Right, so we can draw this graph to see what it will look like. So, this graph, x-axis and y-axis, here's origin. So, y is equal to x graph, that would be a simple straight line. X is equal to 1, it would just be parallel to your y-axis. So x is equal to 1 and your x-axis is just your x-axis, alright? So this would be the area that you have. Whoops, I'll just draw it straight now. Alright, so this is what you will be seeing. Well, this line is y is equal to x, this line is x is equal to 1. And this is, well, you can just write it as y is equal to 0 or something. Alright, so next we take a look at this integration that we have. Now, would you prefer integrate with respect to x first or integrate with respect to y first? Now, if you realize e to the power of negative x squared, if you want to integrate with respect to x first, it is not very solvable, isn't it? So we would want to integrate with respect to y first. So it goes in this direction. Alright, so that means we will be seeing double integration e to the power of negative x squared dy dx. And so integrate with respect to y. It will go from your x-axis to your y equals x. So you have from 0 to x. Well, for your range of x, it will be 0 to 1, alright? So this is what you would have to integrate for. Now you can change this into iterative integration, where you will be separating the terms of y and the terms of x. Right, so integrate from 0 to 1, e to the power of negative x squared. This part, it will pretty much be a constant when you want to integrate with respect to y, since during your integration, you would take all those terms with other variables as constants. And then you have integrate from 0 to x dy and then dx, alright? So you would solve this part first. Well, if you know a little bit of integration, you would be able to tell this is y that you can substitute in 0 and x. So we put in the value and you have integrate from 0 to 1 x e to the power of negative x squared dx. Next, we would be able to put the x squared inside. But of course, when you want to put this x inside, you'll have another half. So dx squared. Now, how about let's just make these two the same. So when you have a negative inside here, we will have a negative on the outside. Alright, so this is what we will see. Now this is pretty similar to just e to the power of x dx, that kind of thing, right? So negative half, integrate from 0 to 1, which we don't need it anymore. E to the power of negative x squared, and you just substitute in the values 0 and 1. So when you put in the value of 1, you have e to the power of negative 1 squared, which is just e to the power of 1, negative 1. Okay, now when you put in 0, you will have e to the power of 0, which is 1. Alright, so this is the answer that you will see. Well, of course, you can choose to factorize the half and leave it as half bracket 1 minus 1 over e. Well, that depends on however you like to write your answer, whether it is just in this form or in a factorized form. Alright, so that will be the answer we have for this example. Now, if you want to take a look at what kind of methods we have used, essentially we start from looking at the kind of graph we have, the kind of boundary we get. Now, with this boundary, we can determine the boundaries of our double integration and the order of our double integration, so that when we change it to iterated, we could just use simple formulas to solve our iterated integration layer by layer, so-called layer by layer, since you want to solve the inner part first, and then at last, using your integration, you can find whatever you have. And so the answer for this question is half bracket 1 minus 1 over e bracket. Alright, so that would be what we have for this example. Now how about let's take a look at one more. Alright, so this is the example we have for the second part. Right, so we are given fx is equal to integrate from 1 to x squared e to the power of negative t squared dt. So after you finish whatever integration you have inside, if you can solve it, that is. So whatever that comes out, it would pretty much be in terms of x, which is what you can have, fx. And we have to find integrate from 0 to 1, x times fx dx. Right. So, of course, when we put these two together, what you would realize is, so since this will be on the inside, you have 1 to the power of, 1 to x squared for your integration, or your outer integration would be from 0 to 1. So x, you could technically multiply inside, which will see x e to the power of negative t squared dt dx. Right, so this is essentially the double integration we are looking at. Now, since we are looking at this part, what would be so special? Can you try to integrate it first? Well, if you realize, if you try to integrate it first, e to the power of negative t squared, if you're only integrating with that, it is not solvable. So in double integration, we would try out different methods, take a look at it from so different perspectives to see if we could solve it. Alright? So when we look at this, we think about what's so special about its boundaries. And when we think about its boundaries, how about let's draw it out. So first of all, we have to be clear what kind of boundaries does it have. We have a t, we have an x. T from 1 to t is equal to x squared, while your x is still from 0 to 1. Right. So you have an x-axis and you have a t-axis instead of your normal, so-called normal y-axis. So you have t is equal to y squared. So we're only in the first quadrant since x is from 0 to 1, so we don't need to consider the other two quadrants, let's say second and third. Right, so t is equal to x squared. It will look something like this. And how about t is equal to 1? Right, t is equal to 1 and t is equal to x squared. So when you have these two and you take a look at x from 0 to 1. When x is from 0 to 1, that would mean it is this region over here. So this region over here, but what is so special? Is there anything you find that is not very right? Okay, so you might realize 1 to x squared. 1 to x squared. 1 to x squared. So when you have it in this direction, it is normally you would have it in a positive direction. But since it's negative, when you want to change it into the so-called correct positive direction, you would have to use another negative. Right, so this is what we're going to see. Now this is what you could be more familiar with, alright? So now we have this information. Can we integrate it? Does it seem like we can integrate it? We still have problems integrating it, right? Now, how about we try some kind of methods we have used before? Since right now here, it seems to be first integrating with respect to t. Let's change it into first integrate with respect to x. That means we have to change those into x as a function of t. Well, here it will still be t is equal to 1. Mainly it's just this originally is t is equal to x squared, so x is equal to square root t, right? So when we change this into integrate with respect to x first, so dx dt, x will be in this direction, so you go from 0 to square root t. And for your t, that will be from 0 to 1. But of course, if you're not sure that this is 1, you could always mark out from your original one that will be t is equal to 1. Right, so this will be the new double integration we are taking a look at. Change that to iterated, and we will be seeing negative, integrate from 0 to 1. So we could take out the e to the power negative t squared, and we'll integrate from 0 to square root t, x, dx, and then dt. So we will integrate whatever is inside here. That will give us a negative half, and integrate 0 to 1, e to the power of negative t squared. So you will see x squared, we have to substitute in x is equal to 0, and x is equal to square root t, and here dt. Alright, so what we have here is negative half, integrate from 0 to 1, e to the power negative t squared, t dt. Now we will put the t inside your dt, so we will have 1 over 4. Well, why do we not have a negative anymore? Later you'll see why. So although at first you just have a t squared, how about let's make the power and whatever's inside the same. So we put the negative from outside inside here. Alright? So this will be your classic e to the power of x dx kind of question. Alright, so we'll have 1 over 4. And this is e to the power negative t squared, substituting the values t is equal to 0 and t is equal to 1. So 1 over 4, e to the power of negative 1 minus 1 over 4. Alright, so these will be your answer. You could also choose to factorize the 1 over 4, and either of these answers, they would work, or even some other ways of changing it. Alright? So this is the answer for this example here. And what kind of methods do we use in this example? Although we are just given two separate integrations and we have to find them. But when you put these integrations together, you'll realize you can change it from so-called, it seems like you're given an iterated form, isn't it? So change that into a double integration, and then you change the order of integration in order for it to be more solvable. And in this case, yes, you can solve it. So then you change it back into iterated with the changed form, and then you have your normal integration procedures. Alright? So that would be pretty much all we have for these this lesson. Alright, I hope that you can understand it, and thank you for your watching.